Hey everybody, Mr. A here, and I'm going to go through a couple of application problems with you, actually 3 application problems, regarding the volume and surface area of the solid figures we discussed last week. In each case of these, we still have to find the volume and the surface area of the object first, and then we're just going to have a little extension from last week to fulfill the other part of the problem. Okay, this same template was emailed to you earlier, so all you have to do now is download this template and open it in Notability, and you can complete your notes as I go through them here in this video. So I'm going to give you a chance here real quickly to read problem 1, okay? This is a chance for you to pause your video and read it, and then mark the text, and then we'll talk about what you marked on the other side, and we'll continue with part A and try to determine the volume of one of these salt shakers. Okay, so I'll pause and let you read the problem, and then we'll talk on the other side. Okay, let's talk about what we're going to do here to mark the text. We need to know that there are 20 tables at the restaurant. That's important. We also need to know that the pyramids have square bases, okay, which is important. And we also need to know the dimensions of the pyramid. So the length of the base is 2 inches, and the height of the pyramid is 3 inches. Okay, so we're going to take all that information, and we're going to find the volume of one of the shakers here. So my volume formula for a pyramid, recall, is 1/3 times the area of the base times the height. Okay, now on my picture over here, I already have everything from the problem labeled for you. The height's 3 inches, one of the lengths is 2. That means that since it's a square, that the other length is also 2 inches. So I'm going to go ahead and fill in all my information. Of course, how to find the area of a square is length times width, or sides squared. So I'm going to do this as 1/3 times 2 times 2, and the height is 3. Go ahead and multiply 2 and 2 together. We get 4 times 3. 4 times 3 becomes 12. And 12 over 3 becomes 4 cubic inches. Okay, so that is the volume of one salt shaker. Now, we need to find out how much salt we need. In part B here, we need to find out how much salt is needed to fill all the salt shakers on each table. Now, the restaurant had 20 tables. Okay, so all we have to do here is take my volume of one pyramid shaker, which is 4, multiply it by all the tables in the restaurant, which is 20, and I get a total volume of salt of 80 cubic inches. And that's the final answer to my problem. And that's how we do problem 1. So that's just how an extension can be applied to give it a real-life application. All right. Now, I'm going to show you problem 2. For problem 2, we're going to use a cone this time. So I'm going to pause and let you read the problem real fast, mark the text, and then I'll meet you on the other side. Okay, let's go ahead and mark this up. So we know that the diameter of the cone base here, we'll highlight this, is 2 centimeters, and the height is 5 centimeters. Okay, and we need the volume formula for a cone. So we're going to do V equals 1/3 pi r squared times h. Okay, now before I start plugging in, I have to remember that I was given a diameter, okay, and I need a radius. So if my diameter is 2 centimeters, that means my radius is 1 centimeter. And that's the number that goes in for r in my formula. Okay? Don't forget that little trick. All right, let's start plugging in numbers. So I get 1/3 times pi times 1 squared times 5. And I'm going to pause it here and let you finish finding your volume, and then we will go from there. Okay, so 1 squared is 1, so we have 1/3 times pi times 1 times 5. So this becomes 5 pi all divided by 3. Okay, I'm going to go ahead now and go to the calculator. Okay, and then we'll also finish problem B in this view also. So I have 5 pi divided by 3, and I get a final volume of this cup of 5.24 centimeters cubed. Okay. Now, read problem B here for just a second, and I'll pause and let you read that. Okay, so on problem B, we are filling up a cup at a rate of 1.5 cubic centimeters per second. Okay. Now, since I know the volume of the cup, I need to know how long it will take to fill the cup up completely. So all I need to do is take the volume of the cup, which is 5.24, and I'm going to divide that by the rate it is filling, which is 1.5. And if I get those numbers and put them in the calculator, then I will get how long in seconds it will take to fill the cup. So I'm going to do 5.24. Let's clear that out. 5.24 divided by 1.5, and I get a time of 3.49 seconds, which rounds to the nearest tenth is 3.5 seconds. And that's the answer to problem number 2. All right, now we're going to go to problem number 3. Okay, and this time we're going to use a sphere. And I'm going to stop here and let you mark the text, read the problem, mark the text, and then find the surface area of this sphere. Okay, so here's what we know. We're going to mark the text. We know that the sphere has a diameter of 50 feet. So we're just going to go ahead and say that that means that the radius is 25 feet. Okay, so our surface area formula is 4 pi r squared. So then I need to do 4 times pi times 25 squared. And 25 squared is 625. So I'm now going to go to the calculator. So 4 pi times 625, and I get a number of 7,853.98 feet squared. That's the surface area. Now, read part B and solve that part of the problem, and then I will finish that problem on the other side. Okay, so for this part of the problem, all we have to do is take 7,853 times 0.98, and we're going to multiply that by 250. Okay, so I'm going to take my previous answer, multiply that by 250. 50. And I get a final amount. The final total is $19,634.95. And ladies and gentlemen, that's just how we do some extensions of these volume and surface area problems. So at any time through this video, if you read it or if you view it and attempt the problems or whatever, and you have any questions, feel free to send me an email, and I will try to get back with you as soon as I can, all right? Otherwise, good luck, and I will see you soon. Take care.